ready to begin? Okay, yep, just let us know to advance slides and go ahead. Thank you. John.
Okay, so can we go back to slide number 2? Okay, so I hope you all can hear me fine because we have the mic sitting on the desk. So if you cannot hear me, please do let me know and we'll figure out. So this session is really a workshop which is oh, okay. Okay, so this session is a practical guide to AI, and we are living in an era where if you are not using AI or if you are new to AI, you're going to be left behind. So it is important that we give you some tips and tricks to make effective use of AI. So this session is really about that. Next one, next slide. We have already had the introductions. قل ربي زدني علما. So just a quick view of the agenda. First, we'll go over what is really generative AI, what is the anatomy of an effective prompt, and then Iftikhar Saab is going to go over a case study of how we built a prompt step by step to get more effective and useful response. And then some more information about what is the importance of having personas and roles in the prompt. And then we'll dive into some of the advanced topics and leave you with some future teasers, basically. Next slide. So this is just, we kind of already know what is going on since November of 2022, since ChatGPT came along, the speed with which the number of users getting to use, okay, I'm sorry. Okay. So the number of users increase astronomically, and we all know about that. So this is the fastest product adoption in history. It has evolved from text generation to cognitive agents and multimodal AIs where you're not limited to text, and we'll talk more about that. And there has been trillions of infrastructure investment. The number of LLMs, they're getting to about like 2,000 different LLMs. And the LLM capabilities is doubling very quickly. And this is based on the data that we have collected from IEEE. So before we dive into, before I hand it over to Iftikhar Saab, can we have a quick poll? Not sure if you can. So 12 out of 14, 13 out of 14 have responded. And Iftikhar Saab, are we able to show the results? Or do I just need to, because I can see the results, do I just need to say it out?
Yeah, we can say this loud. We have not tried to log in. So
okay,
just
all right.
say it. Thank you.
Right, so that's fine. So it seems that most of you, 10 out of the 16 who have responded, use it daily. 2 use it a few times a week, 2 use occasionally, and 1 does not use AI. So now we can move on to the next slide, and I will hand it over to Iftikhar Saab.
Jazakallah. I hope everybody is able to hear me. I'm going to stand. Hopefully it will be better. So some of only couple of slides are going to be repeat from my previous session, just in case if you heard that, it's just repeat. It will just give you similar knowledge again. But most of the slides after 2 or 3 slides are going to be brand new, and we will build a case study. The reason we have put this slide just to have an appreciation of how actually AI works. So I will just put some terminology so that for future, if you're reading about it, if you're researching, it's easier for you to understand. If you're talking to your technology department, you want to make sure you're like educated what they are saying. So that's the intent of first couple of slides. So we say AI as a user, but as a technologist, the software engineer and the data science, what works behind the scene is called large language model. So large language models are actually trained on huge amount of data. So before we understand uh, how it's able to keep all the knowledge that's more than any human knows, in other words, all the knowledge available on the internet, and how it's able to predict what should come next. So just spend like 30 seconds about the how human brain works with respect to neural network. I'm not a doctor, by the way. I intentionally took the example of medicine with the assumption that a lot of people are going to have medical background. So I hope I will explain it as well as possible. But very simply, neuron is just a huge network. A neuron in our brain take a message, process, send it to the next one. So even my one hand movement, that means billions of neurons happen behind the scene. They went through a very complex, maybe the most complex network can ever be exist. It went through that network to send the message to my hand to make that move. So for now we come back to technology. All we need to remember is that in computer, what processor can do is just numbers. Processor does not understand any English, any language. It does understand numbers. So that means we'll take all the knowledge, convert it to numbers so that it can do calculations. Now you can have appreciation of what neural network mean in this case. It's just the layers of information in the form of numbers in a way that when the algorithm is running through that, it can calculate a neuron, meaning a single number. That neuron can say, okay, go to this layer, and then that layer can say, go to this part of the layer, and so on, in a way that it can make a prediction for what word should come next. So that's what we need to take away from this particular slide. When I say layer, I can explain that a little bit so that as a concept it stays there. I just take simple example. Let's say cat, right? So cat is an animal. Cat is a pet. Cat like to stay home. Cat like to maybe drink milk, right? So all the properties about cat, that's what is going in different layers. But then it's kind of just not that much. We in public domain may also know the owner of the cat. So then another layer who have the information about the owner. It may have information about the house. It may have information about so many other things in that relationship. But when it's going to do that prediction, it's going to look at the probability in the context, not just in general. It's not like a static thing. It's a very dynamic thing. It's going to move around. In the context, it's going to have that probability to predict the next word. Okay, let's go to the next one. How models are trained? If we are going to train an LLM, large language model, for simplicity, we are assuming it's text only. But we know the modern models can do image processing, PDF reading, everything, right? So in case of simple model, we will take all the information, all the text information available in the public domain. We will take that, and then we will clean it up first, because there might be something incorrect, there might be something duplication. We will clean it up in a way that we can create tokens, and we start training the model. So when I say training the model, practically it's just keeping that numbers for those relationships. We will call it weight. So know the weight of cat and dog may be closer compared to the weight of cat and animal. Because cat and dog are very common pet. They may go along well. But cat may not met an animal, an elephant, so that's why the weight is further. Again, when I say weight, behind the scene is number. So we took the data, we call it pre-training, model understand that, but it's not ready to like have an interaction with us. That's where fine-tuning come into picture. Fine-tuning, we gave it response also. We said if as a human, if this was the question, this is how I responded. So now model is saying, okay, I know what is the correct answer, let me change that weight. That happened. Last but not least is the reinforcement learning. Now we start telling model, hey, this of your response was incorrect. Then model will learn from that reinforcement learning to say, okay, I will not go that way, I will stay here. So it will change that weight. Just the takeaway from this slide is that, of course, there is several phases based on the type of data, based on the domain. It may take months to train a model. For us, we may not train a new model, but just the appreciation how it works and working with our technology people, it helps. I'm just going to show a couple of slides, have some numbers. So please do not worry about the numbers, just to reinforce some of the concepts, and then we'll come to our case study. So one word that we will hear is called token. Remember, computer understand numbers only. So computer doesn't know what's a word. So it's going to divide that into token, like a unit that computer can operate on. It may be close to a word, it may not. So the generally speaking, if there is like you're writing a paragraph, if it's about 75 words, that may be about 100 tokens. So I just wanted to show one example. Like in first case, we said hello, comma, word. They became exactly 3 tokens. Perfect. But in the other example, I said kingpin is 2 tokens. Right? We do not need to remember any of that because there is algorithm which is doing that. All we need to remember is that if there is a token limit on how much input we can send, we know it's about 75% of that is how much word I can write. I gave the example of cat, and this is also example of cat. Remember we said we in numbers form, we are keeping that information. Think of like a large array and we have several cells where we are keeping that information. This is just showing that. The reason I want to show, because when we come to, we saw the slide, trillions of dollars on infrastructure investment. Why? Because we want to make those faster. We are going, as we mean as the industry, as a which phase we are in right now, is going to have more data. So this technology wise called embedding. So do not worry if you do not remember that. Just remember there is all that information went to numbers. Based on that, we are going to do calculation. So embedding is a way of capture the information in the context about a particular word. Okay, one more, and then we will go back. When I said LLMs are trained, historically, that the way architecture was designed, the way software was built was slower. In 2017, Google researchers, they published a paper. And the way that paper was saying we can design it, it's called transformer architecture. This is just showing like how many layers and how many things are working behind the scene. That's the architecture OpenAI took, then Google took, then everybody took. That's what make it parallel processing. That's why it became faster. So that's one part I want to show here. The main part, I just said this story is about I didn't say woman, by the way. So what I want to show here is that we saw a lot of numbers. We do not need to remember any, but we need to remember behind the scene is end result is that is able to calculate the probabilities. It says, hey, if you are saying this story is about right? So it may be a boy, it may be a man, it may be a woman. So it's calculating those probabilities in the context. Why I keep saying in the context? Because if I say bank, is it a bank like is financial institution, or is it a bank like a river bank? We do not know. But if I say I went to bank to draw some money, we know. So that's how model is trained. So based on that, all the information it had, it know the context also. So long story short, in the other session, there was a question, hey, why choose woman? It's going to choose one of the top few things. That's why it's generative. Because if it's choose top one all the time, it's predictive. It's going to do exactly every time. So now it's very innovative, it's generative. Okay, let's move out of number. Just to recap, large language models trained on huge number of text data. Behind the scene, they are able to calculate those weight. Based on those weight, in the context, they can predict next token. Now we are a user. So just for next 5-10 minutes, we were just trying to understand behind the scene. Now we are just a user. There are different ways to write the prompt. All of us have used ChatGPT. We ask a question. So whatever we are asking is called a prompt. So there are different techniques, and that's what we are going to explore. But in the simplest way is saying we can give an example to the model, or we can tell example how to, or we can ask model how to follow steps, or we can make model very cognitive, not just reasoning. It will start thinking for us. That's the use case we are going to take. We may not have formulated our prompt like this, but actually that's how we should practice, especially at workplace. Because when we are just using chat GPT, we may be just asking, hey, tell me a joke. Sure, it will do that, right? But at a workplace, we have like very specific use cases. So please follow this along, and that's how you should structure your prompt. In other words, give a role to the model. If we don't give a role, model doesn't know where to go. Assume that way, right? So what does role mean? In the context, I may say you're a physician because I may be asking about a medical thing, right? In a role, I may say you are an investigator. A role may be you are an analyst. So give a role. Specify the goal. Like we gave the role, now what we want model to do. Maybe analyze. Most of the time it's going to be a verb. Maybe analyze, maybe recommend a treatment, right? Maybe find out, maybe make suggestions. So give a goal. Context, that's where we are going to build our use case today. Think of it, and sometimes we say, hey, help me to help you. Just think that way. The more relevant information, not all the information, the more relevant information we give to the model, we will get better response. Format, you can just say, technology-wise, there are different formats you can specify, but you can say, hey, give me in bullets, or give me a summary, or give me something within 500 tokens. So you can specify format. Guardrail, you can put some constraint also. So most common one we say, if you do not know the answer, say I do not know. That's very powerful because model is going to generate the next token. If model doesn't know the answer, it is still going to give an answer. That's called hallucination. So you can always say, hey, if you don't know, just say I don't know. And we will see other example. Other example of guardrail. Examples, you can provide example. Let's say you can say, hey, summarize this financial report of Apple, right? It will do it. But then you can be, if you want like a certain way of that getting that summary, you can say, hey, for Microsoft, I said this is the revenue, this is the income, this is the expense. For another company, I said this. Similarly, summarize Apple, it will follow that example. So you can give example. Reasoning and exploration, we will definitely go into that one. Up to here is pretty good, but here is becoming like our brain also. We are going to say, hey, don't just give me answer, explore the options, become cognitive, have a thought process, then tell me what will you recommend. Okay, oh, another question, please do this question.
Yes, so time for the next Menti question. So basically, we are looking for maybe a one-word answer that says, well, how are you using AI in your professional work? Maybe for analysis, maybe to summarize, maybe, write emails in a very short form. Let us know how you use it. So far, we are seeing, and this is a word cloud. Unfortunately, we cannot show it to you. So research, medical documentation, formatting, checking schoolwork, research analysis, presentations, analysis and summary, proposals, writing proposals, getting help, getting flight options, um, getting guidance. So most common so far has been medical documentation, writing proposals, and research.
Jazakallah. Let's move to the next one. So when we have been saying case study, intentionally we put a medicine, easier to understand. I'm not a doctor, but we'll build on top of this, right? So we just took as realistic as possible. So there might be a patient exists there, but we didn't like copy paste it from anywhere. We just made it up, just so you know. That's the disclaimer. So we can read about this patient. We know some information, right? So we know where they were born, how old, smoking, non-smoking. So remember our framework, like those 8 things that we need to send as we should try to send as part of prompt. So let's see which one we did for now, just for now. We set the context. We didn't set any goal. We did not ask any question. We did not give any example. We just gave a context. So this is example of a context. Easy. By the way, any prompt you can run on any of the LLM. But what it will do, it will just give me a generalized answer. It will say, hey, thank you for sharing with this. I think this, blah, 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 blah. It doesn't help me at all. Okay. Now you are a helpful, respectful, and honest assistant. If you do not know the answer, just say, I do not know. And the rest is same. I'm just adding on top of the previous one. Okay. Pop quiz. What did we do now? In addition to context, we gave a role, which was you're an assistant, right? And at least one more thing. Honest answer, meaning constraint, right? So in a way, they gave that constraint, slash guardrails, right? We said do not, yeah, you're right. Guardrails are constraint, we can say either way. Correct, very good. So we gave role, we have context, we said guardrails. Again, you run, it's still not going to help us because we did not even set a goal. It will still answer, right? Okay, let's go to the next one. Top part is same. Now we said recommended treatment for this patient. So we gave the context, now we gave a role out. Sorry, now we set a goal also. Now we set a goal, like, hey, what you should do. We have said recommend treatment for this patient. Okay. Sorry, before I show this. So now remember, large language model, ChatGPT, which one we are using, right? They have information, they know how to generate next token. We gave them goal also. So now they are going to like go in that area of the neural network and try to fulfill the goal. So they want to recommend a treatment. But we said, if you do not know, just say do not know. So in this particular case, I ran all those. The answer came, I do not know. Because if we remember the context, what we said, 60-year-old man from Pakistan, have kids, doesn't smoke, what is the treatment it can recommend? So even we gave the context. So now it's coming to the effectiveness. So making sure that the context and the information we share is very effective. Okay, let's provide more context. Let me click all three. So feel free to read. I will just give a summary. Now, we also give symptoms. So we gave more information. So now at least if I'm a doctor or the model, they can start thinking, hey, what could be a reason for these symptoms, right? We also said what they are complaining about, right? Like what is happening right now. We also gave information about different tests that has already done. Conduction study, right? PET, which is, I think, it's a test, right? We also gave something B12 from the blood work. For simplicity, I could just fit this much on a slide. In your actual workplace, you can send the whole report You can send images of X-rays. You can send the information that you have about that patient in this case. That is actually the context. Model will be able to process all that, right? For our use case, this is the context we are sending. Are we expecting, if we say recommend a treatment, are we expecting a better response than the first one? Yes, no? I think we are expecting better. Why? Because we gave, we gave symptoms, we gave some of the results, right? As a doctor is going to analyze, I should not say as a doctor yet. As an assistant, remember role was assistant, is going to analyze and say, hey, this is what I recommend. We were trying to share a document also, but for no slide. But if you were run, it will still give answer. Most of them was very generalized. It's tried to address each and everything. It says for B12, do this and this. For this, do MRI. For this, do this. So it was able to respond, but still not what we were expecting. And then to become a cognitive. I just wanted to show a couple of examples of format also. This is the easier one. Yeah, right. So when we said provide a short summary, because when I ran that first time, the response was like 20 pages. Now I need another call to say, can you summarize? So I can just set that up in the format to say, please response in a summary form. And there is many other ways to format. So now we have format also. Okay. From the whole thing, I just copied one part. Maybe if you're a medical doctor, I'm sure you know what is happening here, but that was a little bit more relevant when I read it. So just if we see this response, it is appropriate response. It is accurate also, but can I get it closer, right? And I will show that in next example. So in this one, it's able to recommend some medicine, is also able to recommend saying, hey, please do an MRI. Okay. So far, if we evaluate, I already gave up this one. So role, we said assistant. What we are doing is discussing a patient. So that's not that good role, right? So we will change the role. Goal and format is less relevant. Goal, I think, is good, but the context, we gave more context, but we didn't give like reports, whole blood work. We just said B12 is this and this. In actual use cases, we will give the whole report. Okay. Exploration, that's where we are going to do. We have not used that yet. And that's the time for me to take a break. Another question.
Right. So if you go to Menti, there is another question, and it has all the 8 options that Iftikhar Saab just showed. Which one of these options do you usually include in your prompts? So far, no responses. Is it?
It's not allowing to submit, and I think we also got a warning for the time. So I think we can move forward.
Do you see it now?
This one I already gave, right? So instead of assistant, we should say you are a physician. So now we will get better response than the previous one. And that's what you can see. See, previously there was no mention of, hey, maybe take a steroid injection. It was just saying gabapentin or something. So as a physician, it became more closer. So just recap, please make sure you give the closest possible role, just the way we said other thing, and more context, relevant context. Okay. Okay. Yeah, I will be good in 5 minutes and then they will finish in 3 minutes. Now the exploration part. This is the most important, by the way, right? So just please pay 5-minute attention and you will see what it means. We are making cognitive, like, hey, you have a reasoning and thought process. It's not like we are going to say, oh, you are smart, do it. No, we are going to give those steps. We are going to help it to help us. So that's where that example is. Instead of role, we are saying it's expert of panels. panel of experts. Sorry. Panel of experts. Now there is more specialist doctor are going to sit together and discuss the case. So that's very powerful. And we also specified what are those experts that we need in this case: medicine, neurology, cardiology, and pain management. And this is a document, but I have copy pasted. Sorry, we know we are on exploration, so I can go here. So in that one, we can also specify. We should not assume like what model no internal medicine do. We should not assume that. We can specify. So we said you are a panel of experts, but this is what these experts do. So in my original prompt, I have all of them. Please specify. This is where power is coming from. Now we are saying respond to user inquiry, which we said recommend a treatment using a multi-step process. Because you have a panel, 4 people are sitting together, they are going to do evaluation. So we are giving that reasoning and the exploration of process also. Each expert should offer a key takeaway. So as a cardiologist, I will say, hey, maybe it's this and this. So I should share my feedback. Also the counter argument. They may say, maybe it's not. Right? And then this is also to critic to the others, meaning they should like say, hey, neurology should not think about this and this. So they should do that. When they are responding, we will not know because cardiologists say something, I assume that is the way to go. We are saying no. While giving your expert opinion, also share the likelihood. Just say, hey, this is what I think, maybe 85% chance. So we can evaluate, right? So that happened first. Then we are saying to model, take that, no, iterate, go back to them. Because they showed the concern or the critics for others, go back to them, evaluate, iterate, incorporate whatever they said, until you reach a consensus. So this may happen 3 times, this may happen 2 times, this may happen 5 times. Exploration. It's working like a brain. So then this is just format like how we want to show it. So if you have not used this type of prompt, please try it out. Give a role, ask it, hey, you are panelist, give your own criteria. You also give criteria, hey, criteria of success, blah, blah, blah. Okay, I will skip this, but you can see it came way closer to like actual expert with percentage, with saying, hey, what neurology should think, all that. And it also said what were the key conflicts. Then it will resolve the conflicts and so on. I will skip this one because that's what we just discussed. I will just do one more. Yes, okay. So this one is just saying context instruction are important. We saw by example. Okay, here is the last one from my side. So now, large language model can also become a judge. It's very important to understand this because in your workplace, most of us are domain owner. We know our use case, but we work with technologies. So that's where it's become powerful for us to help them. So LLM can also be used as a judge. In other words, I will give an acceptance criteria. I will say, hey, a response came from first call. Please send it to the second call. If here is the criteria, then tell me on that criteria, is it a good response or not? I can also do hallucination check. I can say, hey, typically response should fall in this domain. If it's not falling in that domain, please say it's hallucinated, and so on. So this is where I think my part is done. I just want to recap. Prompt engineering itself very powerful. Think of it an art. We said those 8 things. If you read another article, they may have different names. It's not like industry have all said, but practically this is what you need. In your prompt, you can actually say, instead of saying you're a physician, you can say role is physician, like your role is physician. You can go more specific. It just became more powerful. It gives you more appropriate response. It's really start working like a human brain. With that, I will send it back to Aziza Saba.
Can you, yeah, let's skip this. Right. So all that we are saying is that there is a different set of people in this audience, and based on whether you're in medicine, research, engineering, education, you can customize the role, right? Define the role, and the goal, and it'll give you a more relevant response. You'll get a more relevant response from the LLM. Next slide. We can do that. I'll show you. So these are just like we talked about basic prompting. These are just some advanced techniques like RAG or retrieval augmented generation is when you need to feed in or you need to add some information that is maybe it's proprietary, but you want it to be considered in the LLM's response. So you add it as a file, and when you go to any of these LLMs, when you go to ChatGPT or Claude or any of them, you will see a plus sign, and that will allow you to add a file to add more context or more information to the LLM. We are not going to go into agentic, but this is really a teaser that hopefully in one of the next one of the future presentations we will go more into agentic. The one thing that we wanted to, and then the same for multimodal AI. We just talked about text, but there are multimodal AIs also which work on audio and sound and image and video, all of those, and that's all happening today. It's not a new concept, or it's not something new. Then the last thing that I wanted to point out is that not LLMs are created equal. Right? You may be using ChatGPT, but you may find that the response that you're getting from ChatGPT is not of the maturity level, or it's not getting you the right response. You should go to other LLMs and see for different use cases, different LLMs will work better. Maybe Claude will work better if you're doing research. Maybe if you're only interested in creating images, maybe just stick to ChatGPT. So different LLMs for different use cases. And can we move to the next? Okay, so this is the last slide that we have, and it is very important to consider these. AI can never replace humans. AI cannot replace human wisdom, empathy, intuition, and experience. So this fear that AI is going to replace all human knowledge, it has human knowledge, but it does not have human wisdom. Right? Now, almost all the use cases that you will find must keep human expertise in the middle. AI only supports decisions, humans own them. Right? So it's just saying that AI suggested it and I did it is not a good defense, right? Question everything that any AI tool or LLM is giving you. Question it, verify it, and then interpret the outputs, because it may be just hallucinating, or it may be going on a different context, and that's very common, right? Most important bullet here is do not abandon critical thinking. Without critical thinking, we stop evolving. Use AI to amplify wisdom, not to bypass it. It should not be our go-to tool so that we don't have to think about a problem, right? Because if we did that, then we will not only our brain is going to get rusty, but humanity as a whole is going to stop evolving. Protect privacy and trust. This is very important, right? I mean, because everything that you are sending is going on the internet. It's going through, and even if it's encrypted, it is sensitive data. So be very careful in what information you actually share with AI. And then finally, consider the environmental cost. Right? There is a sustainability cost. Right? There's the data centers being created, being built all over the place. They are consuming a lot of our environmental resources. So we need to be a little more vigilant in making a decision when should we use AI, and what are the things where we should just rely on our own expertise or on our own critical thinking. And I think that's the message that we want to leave everybody with. I think this was the last one, right? This should be the last slide, correct?
I think we just have a few minutes for questions. Anybody on the men's side? Yes.
Assalamu alaikum. Yeah. So I just want to ask, how can AI differentiate between the accuracy of the information that it is getting. Um, I'm using a very bland word. I just want authenticity of information. So if it's searching 10,000 things and their information, we critically we know these are more authentic general places, and then they are less and they are least. So how can AI differentiate?
Jazakallah for the question. Just a couple of things. Remember, in the constraint, we can say that if you're making a code, please give me the reference. Right? We can say that. We can also use as a judge. Then we got the response. We give to another call. We say confirm this code. Is this the correct book name? Is this the correct page number? We can do that. Always remember, it's generated. It may not be accurate. We can do that. The one I was quickly wanted to show, sorry, was the if you're working like on your proprietary use cases with your software engineers, the temperature thing that I was saying, this temperature at the top, temperature add randomness. If the temperature is close to 0, it will always pick first one, always. That's why in the actual use cases, it's a little bit more than 0, so it's a randomness. I have worked on a use case where we need to practically copy paste. The example was that, hey, somebody disputed, hey, my Best Buy did not give me the correct credit. The company want to look at the Best Buy's return policy. It's exactly want to send that to customer, right? So temperature was minimal. So these are the things, just to recap, practically, remember, it's also depend on model, sorry. As Aziza Saba said, not all models are same. A bad actor, somebody can also train a model. They can put all the information, let's say against Ahmadis, and no, not put any information in favor of Ahmadis. That's all model knows. So yes, which model we are using, if I go to top down, that's number one. How we are using it with respect to these parameters available to us. How we are validating the response, that's the third one, and we can use constraints.
A question from the ladies' side.
Ji, Assalamu alaikum. I have a question from both the panelists. Like I've seen in research and all that when you train the model, it becomes more agentic and you use your own different models in one platform, like in Claude or in ChatGPT or whatever the platform you're using. There are certain new developments in that in which they say that use Codex or Opus. How sensitive is that and how you can use that in your daily workflow, especially with research and all that analysis? Ji, Jazakallah.
Do you want to take that, Iftikhar Sab, or I can take a stab at it?
You take this time, please.
So, like Claude has Codex, right? And almost all the, not all, but a lot of these LLMs, they are adding more functionality, which allows the users, maybe not a day-to-day user, but more experienced users to get better responses, right? Right. And for example, we didn't talk about vibe coding, but vibe coding is very is getting really a lot of attention, which is where you don't even have to write a single line of code, but you through prompt you can actually generate code. And Codex and these other add-ins into LLMs, they allow us to do that, and basically allows us to get better responses from the LLMs.
Jazakallah. Just two quick questions. Mononym sir, just one thing. One, I will stay back, so you can ask a question after time also. My name is Iftikhar Khan. Please connect on the LinkedIn, and we can follow through there also. I apologize. We absolutely do not mean to miss this slide. This slide is saying, regardless of how much we know, we still know nothing. So still the beginning of LLM. So that's the purpose of this slide.
Sahab, I just have, so I was doing some preparation for a speech, and I asked, to give me the references, and it gave me the references, and then I asked, no, confirm. It confirmed that it is in this book and such and such and such. So when I went there, it was not there. Then I said, no, you're wrong, because these things were not there. Then it started to say that, no, if you read this whole article, and from there, if you put it all together, then that's the answer. So I'm just saying is, a lot of time, even when you ask references, it just gives you kind of sometime a false reference. But in my experience, I've been very happy with cloud as compared to ChatGPT. Its formatting and all of that is beautiful.
So if I,
Jazakallah for the comment. Go ahead, Aziza
if
Saban,
I
you're
may
saying
just
something?
add something. So that's why we said that all LLM models, they lie confidently. They hallucinate very confidently because they are
Yeah.
told
Jazakallah.
that you must answer, right? So
Exactly.
one thing I just wanted to give an experience that when I was researching for my other presentation, I gave it a prompt saying, only go and look at a prompt to Claude to start my research. I said, only look at Ahmadiyya resources, right? And then I said, okay, Al-Islam is a good source. Go and check out there. It gave me really good resources, but I still had to go and make sure that all of them are correct, that the content it says it found does exist there, but it gives you a good starting point.
Assalamu alaikum. My question is about the tokens you mentioned. Was that like 100 words for 75 tokens or 75 words for 100? About 100 tokens. So that's the tokens are calculated based on the prompt or based on the response or a combination of both?
Jazakallah for the question, very good question. So that number of tokens, if there is a limit, model used to have limit. It used to be like 1,000 token only. No limit is like hundreds of thousands. We do not realize it. That number of token is on the input. So what goes to the model as a prompt, that's where the limit is. So I'm just going to take opportunity to say two more things. The model itself is stateless. We use ChatGPT and we know it knows everything about us. It doesn't. There is another layer sitting on top of that called memory. So when we are using ChatGPT, it goes to memory, it finds the relevant information, it attach that to our prompt. So actually it's way bigger than what we are sending, and then the model response. And there is techniques how to trim that memory and so much. The other word I want to introduce is called context window. So instead of number of token, we can say context window is. Older models had like 1,000, 2,000, now it's hundreds of thousands. Simple question is that is number of token that goes in at one given request.
Maybe one last question from the ladies' side, and then I think we'll conclude.
I think that we don't have any more questions.
Okay, Jazakallah, thank you so much. Certainly, I'm sure the speakers will stick around. This seems to be a very popular topic. Thank you very much. And just a reminder, we have dinner, networking dinner now, and then Maghrib Isha Salat at 9 p.m., I think. Jazakallah.